Alright, so welcome to this video on XT graph. Now you would be wondering, what is the context of slope when it comes to XT graph. So you can draw a slope, which is nothing but a tangent. See, the context of slope is, or relevance of slope is applicable irrespective of type of motion, right? Finally, slope represents something. So in the case of position time graph, whether it is uniform motion or non-uniform motion, it will represent velocity. But in the case of uniform motion, when you draw the slopes, obviously the slope is different everywhere. You can see v1, v2, v3, and what it means essentially is that though the slope is different, yes, yet these velocities are connected through a fixed equation, right? Which is v is equal to u plus at. So these slopes are definitely velocities. Had this been a non-uniform accelerated motion graph, these would still be instantaneous velocities. But the key characteristic in a uniform accelerated motion when it comes to slope on a xt graph is that the value of the slope, if you draw a chart of v versus t and you calculate the different velocities at different instants and then calculate delta v by delta t, that is fixed. So the change of velocity divided by change in time will always be a fixed quantity, and that we already understand for a uniformly accelerated motion. But the key idea is even a uniform accelerated motion has a slope. The idea of instantaneous velocity is still applicable, but we have a straightforward equation, v is equal to u plus at, also available to us. We don't really use any calculus to calculate these slopes. So xt graph, the key idea takeaway is slope is still relevant, but it's much more easy to understand because it's uniform accelerated motion. Thank you very much.